Okay, hi guys. So in this lecture I'll be covering up the dicarboxylic acid. So we'll be looking into some of the names of the carboxylic acids and their general formula. Okay, so dicarboxylic acids. So dicarboxylic acids are the acids or the organic compounds which actually have two carboxylic acids in uh, itself, right? So if we have something like this, then you can actually see that we have two carboxylic acids within the same compound. So such type of compounds are called dicarboxylic acids. Okay, so this n can vary from 0, 1, 2 and so on. Okay, so let's give me some you let us give you some of the examples of when actually n varies, what is the common name associated with the resulting organic compounds or the resulting dicarboxylic acids. So when n is 0, the name of the structure, or simply I can say the structure, becomes C double bond O OH and C double bond O OH. So the name of this particular structure is oxalic acid. I'm talking about the common names, not the IUPAC names. I'm sure you all will be able to derive the IUPAC name for this compound uh, by now. So this is called oxalic acid. When n equals to 1, then this is called malonic acid. N equals to, this is called succinic acid. N equals to 3, it's called gultaric acid. When n equals to 4, then it's called adipic acid. When n equals to 5, then it's called pimalic acid. When n equals to 6, then it's called subbaric acid. So this is a trick to remember all these names. You just remember the first letter for all these words. We'll be deriving a pattern for you to just remember all these names. So the pattern is OMSGAPS, or Ohm's gaps is the pattern. So Ohm's gaps is nothing but it is the first alphabet for n varying from 0 to 6 for the names of dicarboxylic acids. So O means oxalic, M means malonic, succinic, glutaric, adipic, pimalic, or subbaric. So okay, so you can just remember the word Ohm's gaps, and whenever a question comes that you have to name a compound something similar to like this, CO2H, CH2 whole twice, and CO2H. So what would be the name of this as n equals to 2? So 0, O is for 0, n equal to 0, M is n for n equal to 1, S is for n equals to 0, n equals to 2, so S is succinic acid. Okay, so just one more thing I just want to tell you, that they are also called alpha, beta, gamma and delta carbon atoms. Means they are the carbon atoms which decides, means for example, if we are taking we are saying that a carbon atom is an alpha carbon atom. So what do you mean by that? This means that the carbon which is directly attached with the function group is called the alpha carbon atom, which is second directly attached with the functional group it's called beta carbon, similarly and so on, right? So now I suppose we have done the nomenclature for the carboxylic acids. Now I'm moving to the nomenclature of esters. Okay, esters. So what is an ester? I hope you remember from our past videos that this is called an ester. Okay, so this is the principal chain of the ester and this is the alkyl part. Okay, so this is the principal chain and this is the alkyl part. Now the standard which we use in IUPAC name for this type of compounds is alkyl alkanoate. This is the suffix we use for the esters. So alkyl word is derived for the R dash carbon and alkanoate is for the principal chain carbon atoms, right? So let us delve into some of the examples of the nomenclature of esters. Okay, we have something like this. So what would be the name of this? It would be nothing but methyl methanoate or alkanoate. I beg your pardon. Ethanoate. What would be the name of this compound? Again, this is called methyl, this part, and again this methanoate. We have something like this. First of all, get satisfied that this is an ester part only. So accordingly, we'll be naming this particular compound. So it would be, as this chain contains two carbon atoms, it will be ethyl. And how many carbon atoms does this chain contains? 1, 2. The principal chain 4. So this is ethyl butanoate. Okay, let's delve into this. Okay, so what would be this part? This part would be 1 ethynyl, and what would be this part? It would be but 2 in OH. Okay, so let us look into some more examples. We have something like this. What would be the name of this compound? Oh, I forgot to substitute with cyclopropyl ring. Okay, so what would be the name of this compound? This part would be named first. So this is nothing but but 2, or sorry, it's not but, it's prop 2 enyl, and then what is the nomenclature for this part? 1, 2, 3, 4 carbons are there. So 2 cyclopropyl group would be added as the prefix for the second part, and butanoate. Make sense? Yes. Okay, so what about this compound? What would be the name of this compound? First, this carbon atom, so it is nothing but cyclobutyl, and this would be 1 cyclopropyl methanoate. Why? Because cyclopropyl group ring is attached to this carbon atom. Okay, so in the next lecture I'll be taking up some more examples on the nomenclature of ester, and we'll be seeing amide nomenclature as well. Okay, so till then, good luck.